Well, thanks very much, Warren. Thanks very much, Anne. A couple of really interesting talks, just like all the recorded talks earlier in the day. So now the plan is that we're going to open the discussion up for questions from the audience and questions that I will pose, and maybe some of the panelists who include the recorded talk presenters and the plenary speakers. Hopefully they may have some questions they want to ask each other. So please post your questions in the live event Q&A. And I also wanted to acknowledge, in addition to Lila Gonzalez, who has been driving all the tech for this seminar, doing a great job. I also want to acknowledge Chris Lawley from Geological Survey of Canada, who is serving as our moderator. He's going to be helping me keep track of questions. So what I'd like to do for the recorded speakers is to give you a chance to jump on and introduce yourself and let you know your title. Warren and Anne, you've already introduced yourselves more recently, but so Genevieve, would you like to get on and say hi?
Yes, thank you, Geoff. Yes, I'm Geneviève Marquis. And I hope my sound is okay. Anyways, it's a live session, so all sort of technical glitches can happen. So we really appreciate all your patience on that. Well, yeah, I'm Geneviève Marquis, and I'm the senior director of the Central Division at the Geological Survey of Canada, for which the target number one is really achieving the Targeted Geoscience Initiative and the Predictive Geoscience Agenda. We have a super strong and deep interest on artificial intelligence and how we can use this approach to develop our research agenda for critical minerals. So I would say that these are my few words of introduction.
Great, thanks very much. Jean-Yves.
Hi, everybody. I'm Jean-Yves Labbé. I'm the Director of Geological Information at the Ministry of Energy and Resources, Natural Resources in Quebec. I'm geologist in the first years of my my career, but right now for maybe the last 6 or 7 years, I've been doing managing, and I'm now in charge of the CGM database that I presented to you earlier. So we, as you've seen in my presentation, the new plan on critical minerals in Quebec will be quite challenging for us. A lot of new, old and new things. We will be able to do some things that we do habitually, but we will it will be possible to begin new challenges. We talked a lot about artificial intelligence, so that's something we'll be going in. So we already talked with Geneviève and maybe do something together with the Geological Survey of Canada. So it would be a lot of challenging years in front of us. So that's it. Good day.
Great. Thanks very much. And Natalia.
Hi, everyone. I'm Natalia Mezcua from the Mexican Geological Survey, Servicio Geológico Mexicano. I'm the Deputy Research Manager in the Research and Development direction. And we have, as you see, a lot of work ahead, but very interesting work to do. Thank you.
Excellent. Thank you very much. Felipe Espinosa.
Hi, everybody. Felipe Espinosa here. I'm Chief of the General Geology Department in CERNA-GEOMIN, which is the National Geological and Mining Service in Chile. And we are carrying out right now the National Mapping Program, which is a major program in Chile, which, as I told you in my presentation, including the first country-scale geological aerial survey and also the geochemical stream sediment survey. So we have we are part of the geology subdirection in CERNA-GEOMIN with other departments and areas which have been collaborating together to put out this presentation, the mineral resource units special. So that's it. Thanks for the organization. Excellent forum.
Excellent. Thanks very much. And to the next Felipe from Brazil.
Hi, everybody. So here's Felipe from Brazil, and I am very honored to be here today with you and to see all these advances in critical minerals research. And I am very excited with all the collaboration that we can reach from this kind of forum. And I would like to thank especially for the organizers to have invited us to here, and also to the mineral potential modeling and metallogenesis team of the Geological Survey of Brazil that helped me a lot with this presentation. Actually, this work is a collective work, right, from several people and collaborative. And I think that this word is the best word for this moment, especially in this pandemic's time. Collaboration is essential for us in several areas, and also in the geological surveying of the world. So it's very good to be here with you.
Great, thanks, Felipe. And I will give Warren and Anne a chance. Do you want to say anything additional, given what the previous folks have introduced themselves?
No, I'm good here. I'm Warren Day with USGS, and I look forward to the discussion.
This is Anne. This is Anne, and I would agree with Felipe. I think the collaboration is essential, and in a way, it's a really good thing that's come out of the pandemic, is this ability to collaborate.
Excellent. Yes, and actually, that was going to be one of the first things that I was going to mention, is that one thing that the pandemic has provided is an opportunity for us to really make use of these new presentation technologies and communication technologies like Teams. There are always challenges in getting them to actually work, given so many people and things, but I've been really impressed over the course of the pandemic just how much it helps to have these collaborative devices. That said, we certainly wish that we could be seeing people in person, but this also is a great way to reach a much broader audience and have active dialogue between people from many different countries. And I just wanted to pass along, Leila had indicated that as of the 107 timeframe, or 1307 hours, there were some over 300 people online and listening. So again, we really appreciate it. So one of the things I would like to start off the group with a question that I'll basically put out for everybody. But in listening to the recorded presentations and Warren's and Anne's, I sense that we're in a couple of in a period of a couple of really intriguing challenges for geological surveys. One, we're having to have a lot more emphasis on critical minerals, which everybody has basically noted in their presentations. And that given the fact that they occur geologically and as traces of some other types of mineral commodity deposits, but also looking for where they occur in other types of deposits. is sort of requiring a whole new look at economic geology and mineral resources. And at the same time, we're seeing this explosion in technological advances such as artificial intelligence, machine learning, high performance computing, things like that. So my first question to everybody is, as a geological survey representative, what do you think are the biggest challenges that you face going forward? Are they acquiring the expertise? Are they looking at geology in a new way? Are they harnessing the power and learning of new technologies? What would you see are the biggest challenges that you all face going forward? And if rather than name particular people, I'll let somebody just jump in if you want to respond that way. Thanks.
If you mind, I can start. Here is Felipe again. So I think that one of the largest challenges actually is that all of this is very new for us. I mean, like the technologies that we are using and training our teams and learning all the techniques is challenging and thrilling right now. And also, I would say that the development of new and open source solutions based on machine learning techniques and other vital technologies is that I believe that is one of the largest challenges, as well as the organization of our database in order to make it communicatable between that our databases can communicate between each other, so that we can do really nice and remarkable comparison between the data and so on so far.
Yep, those are all great points. Anybody else?
It's Geneviève from Canada. I'd like to highlight 3 challenges. The first one, well, the easiest one, I would say it's the culture challenge, but very important to mention anyways. The geology research agenda is not only boot on the ground, it does require a lot of computing capacity. So it takes we're facing a switch in terms of how we're conducting our research. But I think there is a lot of geologists who are really embracing this switch and keeping in mind that, yes, we will always require some ground truthing, but geology is no longer just a science, it's not just a science that can be conducted in the field, it's a combination. The second challenge, as my colleague just mentioned, it's the data challenge, because it does require a lot of data management at the core of the geoscience program. But above all, what's the greatest challenge? It's not like the capacity of geologists to conduct artificial intelligence, and it's not just the data, it's our computing capacity as a nation. It does require extremely high computing capacity to conduct any experimentation and deep learning. So it's much bigger than we were expecting at the beginning of those experimentation, and now we're facing a challenge where we can see it's not only specific to critical minerals, it's for all science. Like the computing capacity for deep learning is huge, and that's a new paradigm that we'll have to address. Like, how do we organize our computing capacity in the future? And in our case, to address the advances in critical mineral research.
Thanks. Those are all great points, Geneviève. And anybody else like to say anything? I have a follow-up question if nobody else wants to chime in.
Yes, Jean-Yves, maybe I can add a challenge for us. You mentioned it, acquiring the expertise. It would be quite a challenge for us. We have to build the team working on metallurgy. That's something we haven't done in the last 5 or 6 years, I would say. So now we have to regain this expertise and in new substances that we're not used to work on. So acquiring the expertise is a challenge for us.
Geoff, this is Warren with USGS. So just to echo my colleagues' challenges, to put a little finer tip on it, for the U.S., you're not going to believe this, but only 35% of the area covered by the U.S. In the U.S. is covered by detailed geologic maps of, say, the 1 to 24,000 scale, as well as only 7% of the nation is covered by at least adequate geophysical data. And it's really down to about 4% now is covered by detailed aeromag data that like we're trying to get with Earth MRI. So we have a long row in front of us to hoe in order to get up to national standards for a full understanding of our geologic framework. Expertise is also going to be a challenge with, it was alluded to that we've had retirements and we need to bring in new, fresh capabilities that of geoscientists that not only understand geology, but the machine learning applications. And the third challenge I'd like to highlight is beyond the scope of any of our surveys, and that's more existential. Will countries and will the citizenships accept mining in the future for trying to supply the shortfall in mineral commodities? That's going to be a big challenge that we all have to pay attention to and help educate those who are influencers in that arena. Thank you.
Great, thanks, Warren. And I'm going to try to remember your last point because there's a follow-up that I'd like to talk about later on after seeing how the rest of the questions develop. So my next follow-up question to that is what really excites your people who are working in this area, and what do they see as the reasons? How does this fulfill their interest in geoscience or computer science or whatever? What really makes them excited about going forward?
It's Geneviève Marquis from Canada. I believe that what is of interest to our geologists at the Geological Survey of Canada, it's that their natural intelligence is very valued. Like we cannot achieve that without their natural intelligence. No way we can just say, okay, let's dump that to deep learning or AI without geologists' deep understanding of what is an ore system and how the factors are influencing each other. So I think it's their science, and they feel value about this approach and the agenda.
Great, thank you. Geology matters.
I would add to that, here's Felipe again from Brazil. I would add to that observation from Geneviève, the fact that it's exciting working with all these new technologies and see how we can integrate and put together the work of several people that have developed these works in the last decades, and to make all of that, to give a new sense to all this data. It's very interesting, and I believe that my team and the people that work with us are very excited on trying with all these new technologies. And I would say that this moment that we are living right now is really interesting for the machine learning techniques applied to geosciences. We have seen in the last 5 years lots of advances on that. I would say, for example, the ArcSDM innovations that GTK from Finland have added to it recently, like several machine learning techniques for mineral potential modeling. and also many other initiatives that we have seen in other countries as well. So I think that working with these new technologies gives a new sense to data, and I would also agree with my colleague from Canada that the most important is not the artificial intelligence itself by itself. It's nothing if we don't have the brains behind it. And actually the concept that we are working with right now is of the expanded intelligence, actually. The artificial intelligence and the natural intelligence together are bringing to us the innovation that we need to achieve our objectives.
Great. Yep, that I really enjoyed hearing those two responses, and I certainly get the impression from talking with all our folks that as I can across the internet during the pandemic, that there's a lot of the same feeling and enthusiasm across USGS employees as well. And it's just another example of a really great intellectual challenge in so many ways that we all are really rising to the occasion and really working on. So thanks for that. So I'm going to start asking some questions that have been posed by the audience. The questions have started really kicking in the chat, and so I'm looking through. There have been quite a number of questions focused on the aeromag geophysics, and I think there's Chris has been doing some addressing of those questions as well. But Anne, if you want to take a look through those, and I'll circle back around to you and see if there's anything that you wanted to say in response to all of those. And I'm scanning through here. One of the questions that was, I think, brought up by, I think it was Natalia, but here's a following question. I want more information on how to classify metals, as I want more information on how to classify metals as critical minerals, and what are the criteria for that. And Chris has done a great job of defining that, but I think one of the points that I heard was the need, coming from the recorded presentations, was the need, is there a need to develop more standardized criteria across the globe? Is that the question that people are really asking? Because it seemed like every country, depending on their own needs, supply, demand, availability needs, can define this list of critical minerals differently. Would somebody like to jump in and talk about that a little bit? Oh, and as Chris points out, even though there are different criteria, there's a remarkable similarity between the critical minerals lists of the different countries. So any thoughts on that going forward, folks?
Hi, here, Natalia.
Great, thanks,
I guess,
Natalia.
Yes, I guess the classification of criticality for the minerals is still, for some countries, not properly defined, as we have a definition for criticality of minerals, and probably we just need to embrace a criteria and start working together and making proposals and see. Probably some countries might have some other minerals that might face a challenge for considering critical, and but I think the spectrum of classification can be a bit broad, but some basic minerals and commodities will be like at the top of the list. That's just an initial idea.
Mm-hmm. Great, thank you. I'm glad you got a chance to talk a little bit more about that. Anybody else have any thoughts on that? Okay, no other thoughts on that. Well, I will move to a separate question, and I'm reading the question now. Geological services are traditionally attached to their government's policies regarding exploration in general. How do we advance research in a century with the challenge of environmental protection and scarcity, keeping science and or scientific and organizational independence. Yeah, that actually is a question that I also wanted to grow upon and talk a little bit about, given that I think all the presenters in some way mentioned the importance of developing critical mineral resources and mineral resources in general in a societally and environmentally responsible manner using best practices. So are there things that the geological surveys are doing to play an important role in helping provide information that informs best practices for how mineral resources and critical mineral resources are being developed?
Hi, it's Geneviève here from Canada. Well, thank you, Geoff, for this question about well, the race for critical minerals and where are we in terms of our assessment of our resource in critical minerals. One thing that I would like to mention, and it's coming from my colleague, Dr. Wouter Bleeker, who told me many times that the race for critical minerals, technological or approach is not over. We don't know yet in terms of the battery and the electric vehicle, what will be the top critical minerals needed for our future, protecting our environment and for our green economy, and also achieving our net zero carbon economy by 2050. So we have to play on many fronts. Right now, the research is really broad on critical minerals, and hopefully in the future we can be more targeted. We're reaching out on many fronts right now. It's broad, and we're in the infancy of that research agenda. But hopefully in the future, and with the support of all the engineering, technology, research to advance the possibility or understanding of what are the optimal critical minerals, especially for batteries and reducing our, well, for electric vehicles and reducing our carbon footprint, we will find something that is more targeted. But right now, I can say that the research on the critical minerals is really broad, and my expectation, the trend that we should expect in the future, is to be a little bit more targeted. Thank you.
Thank you. Are there any other questions that, or any other people on the panel that would like to comment on environment, sustainability, things like that? Okay. This question, the one point that I wanted to make is that when one of the areas of emphasis of the USGS has been for probably the last 30 years that we can use the geologic characteristics of mineral deposits to help understand what are some of the potential environmental considerations that need to be looked for, and therefore can they be better mitigated or prevented. So this is a case where economic geology knowledge plays a key role in another entirely different area, but it is very important. So what are the trace metals that are associated that might be viewed as potentially problematic if they were to get out? How are they transported? How are they mobilized? And what can we do to help work with engineers to come up with ways to prevent formation of acid mine drainage or things like that? And that leads to a question that I saw in the published list about that I actually wanted to bring up with the group, and that is the consideration of looking at mine wastes as resources and or slag or tailings. Are there things that people would like to comment about that?
This is Warren from USGS. Geoff, you point to a really critical issue, and that is if we're going to proceed with sustainable mining and try and help close the resource gaps, we're going to have to look at areas that are currently disturbed. And for the US at least, our understanding of the metal content in even large tailings areas is woefully inadequate. And so, you know, you're really pointing to a new future area for all of our surveys to try and focus, to characterize the potential resources that are actually on the ground and have already been dug. So I think it's a wonderful opportunity. Thank you.
Great. And I think, Felipe, was that you that wanted to join in as well?
It's Jean-Yves in
Oh,
Quebec.
Jean-Yves, sorry.
Yes, about tailings, mining waste. I didn't mention it, but the Quebec's plan for critical minerals has some actions regarding mining waste. I didn't talk about it because Geologic Quebec is not really involved in it, but there's something on mining waste. For example, there's a lot of waste from old asbestos mines that are full of magnesium. Mm-hmm. So there's some projects right now that are working on trying to exploit this magnesium. And there's a few weeks ago, Rio Tinto announced that they were going to extract scandium from some of their titanium mines. So it's not waste, but they're exploiting scandium from the ore they're already exploiting. So yes, I think there's many possibilities for critical minerals to be to find critical minerals in mining waste and tailings.
Great, thank you. And you mentioned it. Oh, go ahead. Sorry.
I'm sorry. I can go after you.
Nope. Go ahead. Go ahead.
I was just going to mention that to Brazil, like I said before, potash and phosphate are also critical. So I can give you the example here as reusing the mining waste of some kind of quarries, for example, that we are using as unconventional remineralizers for the soil. And I think this initiative is very interesting, but it's very small scale yet. We are dealing with the necessity of reducing the tailings and the mining waste, and this is an example of how we can contribute to that. But actually, the mining waste and tailings are a very critical theme here in Brazil, especially after some major accidents that we had in the last years. So the federal government is working on that, and we are participating, but not directly. And I believe that the key point here is that we need to reduce the waste. Even if we can take out of these critical minerals, it's very important. But the most important is that we need to bring to the mining industry the idea of a circular economy, and in somehow that we can reduce the impacts that this waste can bring to the environment. And so I believe that this is a transverse theme that brings together several agencies and the industry itself. So I think it's very important.
Excellent, thank you.
May I say something?
Yes, absolutely.
Oh.
Yeah, Felipe from Chile. Yes, we as Felipe said, we also have some initiative here in Chile to extract some minerals from tailings. But I would like to point out the last things Felipe mentioned, that we deal with the other challenge to be attractive for the industry, for the the markets, to put out all the technologies required, all the analysis, all the concentrations, the metallurgy, the concentration techniques, engineering, etc., for making it attractive, for investment. So this is another challenge beside the scientific and the geological challenge to use those brilliant brains that Genevieve mentioned, that we are lucky enough to have that in the geological service, working for our countries. So we have to somehow engage with the look for the best ways to engage with the industry, for the markets, to say, okay, this is the knowledge we put out in our reports. So you have to engage with the universities, investigation centers to look for a specific production line, to put out this like an economic feature.
Okay, great. Well, thanks. I think we'll move on to another set of questions based on what I'm seeing in the published list, and then we certainly have a lot of those. And one of them brought up Dr. Lebay's presentation for the new database that's easily accessible online and provides lots of geological information, the scale of deposits with a nice map interface. And I know Canada is working on Geological Survey of Canada is working others with the three countries are working on an interface for doing this. So I wanted to have a little bit of a discussion about online databases, online decision support systems, or things like that, and what are the challenges that your surveys have faced in putting those together?
Hi, it's Geneviève here. I can talk about a few challenges of pertaining to the databases. The situation in Canada is the fact that exactly what Jean-Yves explained, a lot of the data assets are with the provincial and territorial geological survey in Canada. So yes, the Geological Survey of Canada has some significant data asset, but really a lot of that data are with provincial and territorials, and also with the private industry. What's a really big challenge is to come up as a nation to build our geological data assets. The data assets is really what will bring us at the forefront and being more competitive on the geoscience research agenda for critical minerals. So this is a really big endeavor to build a national data assets that will include not only the GSC data, provincial territorials, but also industry altogether. So, whoa, that's a big one. Thank you.
This is Warren Day with the USGS, and just following on your points, we recognize this need for some common entry point for minerals information at the USGS, and we're trying to build that up, and it's going to take time. But so through our usgs.gov Earth MRI website, we're pulling together a lot of different data sets that are coming at us from the different states, and we're asking for that to be put in a common format. That's the only way we can see going forward there. The other thing, within the US, there really is no common easy access to where are all the boreholes. Where's the information? The information, as you said, is held by our state geological surveys, the public information. And so we're just starting now on developing some prototype interfaces so that the user can go out there and gather information on boreholes across the country. And we're having to, we need to do that with partnership with our states, but it's going to be a patchwork for a while until people get the idea and get pulled together on this. So I see that as a long-term challenge to bring information to a common access point.
So may I say something? Felipe,
yes.
From Chile. So fortunately we do not have that big problem because we are only one geological survey in Chile. We are not that big country as yours, but one of our major problems is to make this data. We have our nice web portals with all the information concentrated coming from Cerna Geomin directly, and also the portal that told you the CHEX, that where the companies put their information. So our main goal right now, I think, it's to create the necessity, you know, the need for the people to know that all this information is available on our websites, and they can access, and also for decision makers, you know, to understand that this information is available in SIG-based platforms or whatever, PDF, interactive. But to create the needs for this information and to put the geological data in the resource areas, or the hydro, you know, or the risk management, you know, all the information is available, and we need to create the necessity and to make the people to understand that this information, it's a very good point to start to make a decision with others kind of information. So for us, this is a very big goal.
Okay. Excellent. And there's a lot more that we could be delving into about that, but I think that's going to be one of the very interesting things going forward, a lot of those different types of challenges, and also looking forward to a lot of similar online products that will be coming out in the pipeline from a number of countries. I think that will be good in the future. So here, this is an interesting question that was posed. Are the panelists optimistic that the mining and minerals industry will be able to supply the critical minerals necessary for the projected rapid expansion of green technologies? Wind, solar, battery storage, EVs over, say, the next 30 years? Who would like to take a crack at that?
It's Geneviève here from Canada. It's true that from geological modeling or system modeling to the exploitation of a mine site, it takes a lot of time. It doesn't happen overnight. And plus, we have a lot of lesson to learn from the past, especially from, for instance, during the World War II, when a lot of other critical minerals were needed. There were a rapid growth and expand on the mining industry. With also the diminishing and the decreasing of the mining exploitation, leaving sometimes some mess behind. So there's some lesson to be learned from the past, and we have to remember that where we're from and why, like the best practices, and of course, like yes, we have to increase the speed of finding new ore deposits to support the critical mineral research and the race for critical minerals. But at the same time, we have to be really cognizant and understanding of all the social concerns about the rapid growth for the mining industry, and it's really important to have an open dialogue with the industry and also with the local communities, in particular with the indigenous communities.
Mm-hmm.
Thank you.
Yes, thanks for bringing that up. Any other thoughts?
Yes, here is Felipe again from Brazil. So I would like to add to this point that I believe I am optimistic because I am an optimistic man. But what can I say? I believe that this issue is divided between two fronts. The first front has more to do with process engineering and the capability of extracting the critical minerals as coal and byproducts from deposits that are already under exploration or that has this potential that need to be understood better, and the tailings and everything like that. So there is this process engineering issue that we need more efficiency, and how can I say, we have new technologies like the graphene fighters and nanotechnology and other teams like that certainly will develop very fast in the next years. And I hope that our colleagues from the process engineering are working as hard as us to resolve these problems. And the other issue is the geological issue related to the exploration. As all of us know, finding new deposits is each time more difficult, and we have to go deep. This is the answer of the question. To find new deposits, we have to look deeper, and geophysics in all the world, advances in deep geophysics methods is very important for us to understand these critical mineral systems that are buried, so that we can find the deposits that these critical minerals are related to. And how can I say this? To make that possible, we need to standardize parameters like geochemical baseline and petrophysical parameters for several rock types, and make libraries that are not national but global for those parameters. And so that's it. I think that I am optimistic, but I believe that we have a lot of work to do with process engineering, recovery of these materials, and the exploration itself.
Hi, Natalia from SGM.
Yes.
I just add to the comments of my colleagues that as is pointed, the best practices and the transparency in the sector is required. Also, automatization of the processes will be required. But there's also an important point of sensitizing the society that the transition to this new green economy or green technologies and low carbon technologies or energies will require minerals, and we need to find this balance to have access to these new ways of living, but also using sustainably the resources we have in our nations.
Mm-hmm. Excellent, thank you. And we're pretty quickly running out of time. This has gone by very quickly, only 10 minutes left. But I'm looking through the questions. I'm going to come back to a geologic-based question. And there was a fairly long question in the notes in the questions that I'm not going to read, but there's an interesting question about how what the current approaches, they focus on identifying current day, future associations geologically, but does not directly consider a geodynamic context in an evolving plate tectonic sense. I'd be interested to hear how the feelings of the panel on how might link geodynamics and evolving plate tectonics into I think, critical minerals interpretation and critical minerals geology.
This is Warren with the USGS. You know, the Great Basin province in the U.S. is actually an exposed terrain that is very active tectonically, and certainly over the last several years. But what we're doing is actually partnering with our Department of Energy there to try. It's a area rich in geothermal resources, and those geothermal resources are fed by heat sources at near surface heat sources and groundwater. And we're also seeing that the critical minerals themselves are associated with those kinds of settings. So we're trying to do that where we can get at them at the surface. And we're fortunate to have the Great Basin as a lab for trying to get at that question.
Thanks, Warren.
Hi, here, Natalia, SGM again.
Yes.
I guess these active tectonic settings and current geological processes are interesting because they are opportunities to see present-day analogs of some mineral deposits, like in some active zones in the marine like massive sulfides and other deposits that are actually being formed. And I guess this new frontier for research, not only for mineral and also but for geothermal and other type of resources, is very interesting.
If you don't mind, I would like to comment as well.
Sure.
And link with the last question that happened here from Hamish Sanderman, that points that the basic geological knowledge is also important, and I totally agree with that. And actually, geodynamic settings are extremely important, and to understand the deposits itself, by in any case, not just the critical minerals, right? And I believe that the key point here is that we need to fill some gaps that we still have of knowledge, especially in the basic geological knowledge. In the case of Brazil, where, like US, we have very little of the country mapped on a proper scale. We have lots of mapping in regional scales, and we need lots of basic geological mapping. And this will be an issue regarding the founding in an environment in a time that the investments may be more difficult, and but it's essential. And to link with the geodynamic setting, I would say that the opposite is also true. I mean, when we are dealing with the Precambrian shields, especially the Archean areas, this inversion, I mean, like the geodynamic settings that we still don't know exactly how worked on that time, is very important, that we need to advance with the basic geological knowledge so that we can understand it better. So that's it. I think that geodynamics is essential for understanding the mineral systems and the critical mineral systems as well. And the basic geological knowledge that needs to be produced is very important for that.
Excellent. Thank you for all of you for your very thoughtful responses on that. All excellent points. I thought at the very end I would circle back around to what has, having been trained as an economic geologist way back in my Precambrian time of my career, one of the things, this plays into something that I've been worried about as I've seen things develop over the years. And this was made in part by Hamish in the questions, Hamish Sanderman from Newfoundland. Let's not forget basic geological knowledge training and data gathering must be integrated with AI. And then I saw Chris Higgins, hi Chris, raised an interesting point about, oh, here it is. How are geological surveys and mining companies communicating with academic departments to emphasize the need for educating students in traditional geology in combination with new technology, modeling, machine learning? And I saw Anne McCaffrey wrote a response. So Anne, I'll call on you first, but before we do that, just in case I have to leave, I wanted to really thank Chris Lawley for doing such a great job of answering the questions, and some of the other panelists for answering the questions. For those of you that posed questions, Leela's going to compile all of those, and we'll see what we can do after the fact to get them answered as well. So thanks very much. And Anne, you're up for the training. And then we'll talk about the economic geology training, which I think is so critical in basic geology.
Thanks, Geoff. I just wanted to say, you know, I completely agree with Chris that training is really important. There's a deficit in potential field geophysicists, for example. And I know that Brazil is training lots and lots of geophysicists in their universities. And I'd love to see that happen more, along with economic geologists, along with exploration geochemists. So I'm just saying, I agree, Chris.
And thanks, Anne. And how about the economic geologists and basic geologists? What are your thoughts?
Well, this is Warren again from USGS. From my perspective, our best allies in this are our state geological surveys, who are most of whom, or many of whom, are nested within the university systems. And so if we can support them for basic data gathering, it really does bring in a new crop of young geoscientists to help us move forward. So that's where I can see the hope of our future from my window within the Earth MRI initiative.
I just would like to add that this collaboration hack contests that we have seen in the last years, challenges that are very interesting. They are very good ways of involving the students on these initiatives. And I believe that we really need to work together with the academy in order to think about how these geologists that are coming out from the university can be already up to date with all of this transformation that we have been seeing in the last years.
Great, thank you. Again, I want to thank everybody, the panelists, the live presenters, Leela, Chris Lawley, Geological Survey of Canada, Geoscience Australia, USGS, and the sponsors of this, AGI and WCOG, and thanks to all of you who have put up such great questions and listening in. Thanks very much. I'm glad to see the positive response to the seminar, and this will be the first of two more coming. There will be the first, and then there will be two more coming. So thank you very much. We will call this to a close. Thank you again, folks.